This is an actual picture of how the universe looked like 13 billion years ago. The universe itself is 13.7 billion. So how did we manage to take a photo of the early universe? The answer is this: the James Webb Telescope, the largest, most powerful, and most complex telescope ever launched into space. And it can take photos just 100 million years after the Big Bang. This video is about telescopes, how they work, what they can do, and the genius of this one. There is a limit to how far our eyes can see. When an object moves further away, there will be a point where there isn't enough light bouncing off it into your eyes to see. This is where telescopes come in. Telescopes need to do two main things. The first, gather as much light as possible. Second, is to increase the viewing size of the object. The better the telescope does this, the more effective it is. This light collecting ability is determined by the telescope's diameter, most commonly known as aperture. The higher amount of aperture, the more light collected, the more information received, and the better you can see faint objects. One way to achieve all this is by using lenses. These curved pieces of glass refract light, causing light from the air to bend as it enters the denser medium, the glass. The first ever telescope used lenses, created by Dutch lensmaker Hans Lippershey in 1608. The design consists of a curved lens at one end, which focuses the light towards a second lens. The second lens is the eyepiece, whose job is to capture that light, magnify it, and spread it over your retina. Because this type of telescope refracts light, this became known as a refracting telescope. Galileo even created his own telescope based on this design, and used his own to observe the phases of Venus, the moons of Jupiter, sunspots, and much more. This design worked, but introduced a huge problem that would prompt the creation of a new telescope. You see, the glass used in lenses absorbs many wavelengths of light. Different wavelengths of light bend at different angles when the light comes from the air to the glass. So the lens is unable to focus the colors of the light at the exact same position. This creates a fuzzy rainbow effect in the image, called chromatic aberration. To fix this issue, Sir Isaac Newton invented a new type of telescope. One that, instead of using curved lenses, would use mirrors instead. These telescopes are called reflecting telescopes because of this. The telescope takes in the light towards a primary mirror. Then, the light is bounced towards a secondary mirror. The secondary mirror then reflects that into the eyepiece. The design allowed for no chromatic aberration. There are also hybrid versions of telescopes, which mix lenses and mirrors. But visible light is not the only kind of light telescopes can see. And that is what leads us to the James Webb Telescope. Using this telescope, you could theoretically see the dinosaurs on Earth if you were far away enough. Since the space between objects expand, light does too, and it becomes redshifted, going in the infrared spectrum of light. This is how the James Webb Telescope can take photos from 13 billion years ago. It can take photos in the infrared range. The James Webb Telescope has allowed us to take some stunning photos, and is a great example of how science has changed the world we live in. If you enjoyed this shorter style of video, please consider subscribing. See you next time.